Greetings and welcome, friends. Mr. Waddy and fellow geometricians are here collaborating, talking about perimeter and area in the coordinate plane. We can take our polygons and throw them onto a grid and talk about their vertices as having coordinates, ordered pairs, and we can then use formulas like the distance formula, or we didn't need midpoint formula in this case today, but then we can use those to determine their dimensions and calculate perimeter and area. So, but first we talked about polygons in general. We could classify them by the number of sides. So here's a 1, 2, 3, 4, 5-sided polygon, also referred to as a pentagon, right? And it looks like this would be what's called a regular pentagon, but I cannot assume that. Whereas if all of these angles and all of those sides were congruent, that would be a regular pentagon. Later on in the course, we'll talk about finding the area of regular polygons, which actually we'll have a formula to calculate that. So not sure if that's actually the case, but it's a pentagon. And this is convex. Because there's no dents in it. This one you can immediately see there. Here's a dent right there. So this is concave. And this looks like a hexagon, a 6-sided hexagon. And it looks like these are congruent, and it looks like these are congruent to each other. So I'm just labeling those for fun. But that is probably not true. Super illegal to make those assumptions in the world of geometry. Here we go. Then we started throwing polygons on a coordinate plane, playing Battleship or something to that effect. Let's see how well I can plot points. You are at -2, 4. There you are. V is at over 3, up 4. Oh, how convenient that these are horizontally oriented to one another. Oriented and orientated are both equivalent words, oddly enough. I think that's always weird. Oriented and orientated, or disorientated as well. Yeah, and disoriented. Weird. W is at 3, -4 right there. Dub. Represent. Let's see. I'll draw a nice little triangle so you guys can fast forward this if you want. Look at my beautiful drawing. Ooh. Oh, nah, that's terrible. Terrible drawing. Ooh. Yeah. Yeah, let's see. La 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 la. Anyways, so I'm gonna find the distances here. They wanted the perimeter in this case, which means I'm gonna have to find all of those distances and add them up. I think that for these horizontal and vertical ones, I trust that you guys can kind of start just counting boxes. Almost. But for UV, I'll do one formally and then one informally. It's going to be the absolute value of the difference of their commonly oriented coordinate. So U and V are horizontally oriented, so I would look at their x coordinates, the horizontal coordinate, and subtract them and take the abs val. So I'll have abs val -5, and that's equal to 5. But notice that's the same thing as if I just literally counted the number of lines that it passed through. And so that's what I'll do for this one. This one is 4 above, that's 4 below, so that's a distance of 8. I could use Pythagorean theorem. It looks as though these are perpendicular. I believe, depending on your Algebra 1 experience, that you might know that they're perpendicular because horizontal and vertical lines are perpendicular. There's also a way you can run a check using slope. You guys know that property? Perpendicular lines on the coordinate plane. Do you know how their slopes relate to one another? No. All right. Well, either way, we cover it later on in this course as well. And let's see. Let's find U dubs, and let's see how accurately I can do the distance formula. So I'm gonna do a U dubs. So this point and this point. So x2 minus x1, 3 minus a -2, I'll call it, all squared, plus y2 minus y1, all squared. So that's going to equal 3 plus 2 is 5. -4 minus 4 is -8 squared. And so that's going to be the square root of 25 plus 40. Squaring a negative makes it positive. So it looks like square root of 65, which is, did I already make an error? 64. This is, all right. Negative 4 minus 4 becomes more negative, so it was negative 8. Yeah, why did I get 40? Oh, I was thinking like 5 times 8 already. Wow. All right. Well, anyways. And then 60 plus 20 is 80, 89, so square root of 89. All right. That's more like it. And we could get a decimal approximation of that. Square root 89. And that is 9.434. And if I now, for the perimeter, I just simply add all these up. So I'll do that plus 5 plus 8. And I get 22.434. And these would just be in linear units, whatever units that would happen to be. All right, so this was just like kind of like implementation of the distance formula, or I guess distance formulas, if you consider kind of the commonly oriented ones. All right, and then we had area problems as well. I'll plot this one in purple. Over 3 up 1, there is E. F is at over 3 down 2. And G is at negative 2, negative 2. Oh wow, this is perfect. Let's see, and I'll draw my nice straight edge lines. Look at this. This is, oh man, that does not look straight. There we go. How are you guys doing today? You doing good? You liking the geometry, I hope. Oh yeah, what kind of, is it an everything bagel? Poppy seed? Alright. I've been getting some everything bagels lately at Aldi's. They're super cheap. Probably not healthy at all, but Aldi's is super affordable for my family, and I like feeding my kids, so. Oh, wow. New York bagels. Wow. So that's a for real bagel. So let's see, I can find these distances because they're horizontal and vertical, so that's super easy. I just count the boxes. The diagonal I don't need, because the area formula for a triangle is half the base times the height. And a height is going to be perpendicular to what we decide is our base, and going to the vertex opposite of our base. It is possible I could call, if I wanted more work for myself, I could have described this as being the base, and then the height would have been something like this. But that's just like, why don't make life hard for yourself? Come on, right? Mathematicians, I like to claim, are efficiently lazy people. We like to find the easiest way to do something with the maximum output. And so, yeah, why would I make more work for myself? No, thank you. And so let's see, this is half of 5 times 3. Neither of those are even, so this is just going to be half of 15, or 15 halves, which is 7.5 units squared in this case, because area is literally talking about how many little squares did I fit in here, and they're saying I fit 7.5. Sometimes in terms of figuring that out, you could actually even like see like this little triangle here. You might be able to imagine, could I fit that right up here? And like try to like estimate and count these boxes. Here's a little triangle. And like you might be able to fit that one right here. And so that's something like that you can kind of do at times. You might be able to take this half trapezoid and maybe that fits right here. Right, so there is a way like you could kind of be like, oh, I see a total of 7.5 squares when I kind of rearrange them all together. But yeah, we have more accurate ways of doing that now. All right, for this boss fight problem where you had to kind of pull all your skills together simultaneously, I've pre-done some of this for us. Where yeah, so it was like a lot of distance formula. One of the things I want to point out, a really big idea, is that the diagonal of a square is not equal to the side lengths of a square. All right, sometimes people assume that this is congruent to those, and that is not the case. Later on, we'll talk about that special triangle, special right triangle formed by that. But notice, even at a larger scale, here is a diagonal of 4 on this triangle, and notice that the legs of that triangle are not 4. Yeah. So just be aware of that. So the orientation of this is a little bit inconvenient to work with, but you can just do a whole bunch of distance formulas, and then you found the perimeter and did stuff like that. Let's find the area of the entire solid by adding up the areas of all of these regions. So the area of the triangle, the green part, would have been half of 4.24 times, and this is probably part of a little bit of a previous problem, 2.83. That is, I guess these are all estimates, aren't they? Actually, maybe I can super shortcut cheat my way out of this, so I don't have to plug in a lot of things, but maybe I should be. I don't know. No, I'm not going to find this very quick, am I? ABF, triangle ABF. All right. Wow. I thought I was going to be fast, but I'm not. Wow, it's claiming this is exactly 6? Wow. Interessante. Let's see, 2. Huh. Well, anyways. All right. Tell you what, I'm going to verify it anyway. 4.24, because these are truncated decimals, it won't be exactly 6. Multiply by that, yeah, divide by 2, I get 5.9996. So, yeah, it works out to be 6. This one actually has an area of 4, which is intriguing. And this one, it's perhaps more obvious that I could, take this triangle and add it here, and this triangle and add it there. What's up? I'm a fan of like 3 usually. 2 or 3. Yeah. That's usually what I'm thinking. Let's see, the area of the rectangle would have just been base times height, so that would have been 5.66 multiplied by the 2.83. And let's see, this one's actually going to be an exact value as well, isn't it? 16. And the area of the little blue triangle would have been half of 2.83. And multiplied by, yeah, if this is the base, then I'm calling this the height. Another 2.83. And this one is 4. So the area of trapezoid here, red, I want an orange. The area of the big shape is just going to be 6 plus 4 plus 16. And that's going to be, what, 26 units squared. Right? So, thanks for watching, internet friends, mis amigos de el internet. Tienen un día el más bien del mundo.